us from. Good morning, good afternoon, good evening. We're glad to have everyone here today. This is a long anticipated webinar series, and this is the first of a 3-day webinar series. And you're going to have a very good time all 3 days, right? And this is just a build up to the main event that is happening on 11th of June, 2026, live at Federal Palace Hotel. My name is Dumohera Prince, and I'll be your moderator for today's webinar. On behalf of Authorized Integrated, an advanced tier AWS partner, it is my absolute pleasure to welcome you to One with AI, powering mobility and the electric vehicle ecosystem with Amazon Web Services. Before we dive into today's session, I want to take a moment to give you the full picture of what the series is, what is building towards, and why I believe the timing is perfect and very important. What we are joining today is not just a webinar, it is the beginning of a conversation, a 3-day conversation actually, about one of the most significant technological and economic transition that is currently happening in the whole world, not just in Nigeria. The transition to electric mobility, the shift to clean and intelligent energy, and Nigeria's place in that future. Right, so over the next 3 days, we'll be covering the full electric vehicle and mobility ecosystem, from the fundamentals to how electric vehicles work, to the cloud infrastructure that powers, to the business models, to the policy landscapes, and then the real world to organizations, individuals right here in Nigeria. Each day will be so we'll understand the electric vehicles ecosystem, and then we'll see how AWS powers innovation across modern mobility. And just briefly about the main event, this is something I'm genuinely excited to tell you about. So this webinar series is not the destination. This is just the preparation. On the 11th of June, which is 3 days from now, Authorized Integrated will be hosting the main event, One with AI, live and in person at the Federal Palace Hotel. Look forward to expect keynote addresses from AWS, live exhibition, and then conversations and networking. So back to today, let us focus on today, because today's session alone is packed with a lot of value. We have a speaker today that is going to start the conversation, talking about the introduction to the electric vehicle ecosystem, and then the backup, which is the technology aspect on AWS. So I have the pleasure to welcome today the first speaker of today to take over the first session. Let us make welcome without further ado. Please let us see your reactions on YouTube. Let us see your reactions wherever you're joining us from. Let us see those reactions as we make welcome our first speaker of today, Rejoice. Rejoice, over to you.
Hi everyone, good afternoon, wherever you are. First, I'm glad to be here. Can I share my screen? You're
Yes,
muted.
you can.
Can I share it? Oh, okay. Give me a minute.
Yeah. You can add it where you see present or invite, add it there.
All right, thank you. Okay. Please confirm if you can see. Okay, you can see my screen. Okay, so I think this flyer uh is covering. Okay, thank you. So can you see the school screen now? Just confirm if you can see the full screen. I'm not sure.
Yes, you can.
All right, all right then. Thank you very much. Apologies everyone for the whole setting up and all. Glad to be here. All right. Hi everyone. Hello once again. My name is Olibenga. My name is Julius Olibenga. I am the founder of Trilease. Trilease is an early stage startup company in Abuja, Nigeria, and we are focused on helping logistics operators who are struggling with the increasing fuel prices to easily transition to using electric vehicles for their operations. I'm glad to be here and to share my knowledge about the electric mobility sector. So I'll be taking the topic on the introduction to electric vehicle ecosystem and how AWS powers innovation in modern mobility. So before we continue, I want to basically lay the foundation of what an electric vehicle is. Electric vehicles, or EVs, as some of us know it, are a type of automobile powered vehicle, either fully or partially by electric motors. So unlike your traditional cars that solely rely on the internal combustion engine, we have EVs. EVs draw energy from electricity that is stored in the batteries to propel the vehicle, much like how the battery in your phone powers the phone to come on, right? So when you charge it, electricity charges up the battery and the phone comes up. It's the same way that electricity charges up the electric vehicle and it comes up and is able to move. And these vehicles are actually quite they're very quiet and they're smooth and they're responsive experience, and they also significantly reduce our dependency on fossil fuel. So that's what EVs are. I was going to lay that foundation before we continue. So moving on, why mobility needs to change. So I was taking us in this slide. I was talking about why mobility needs to change, and I'll be using Nigeria as a point of view because that's where I'm based. Now, from definition of electric vehicle that we used in the first slides, we learned that EVs help us to reduce our dependence on fossil fuel, which is fossil fuels such as crude oil or natural gas. Now, if you're living in Nigeria or any country, you have been affected in one way or the other by the rising cost of fuel. Now, for example, in Nigeria, when moving from A to B, it usually costs like 500 naira, like probably like a year or 2 years ago. But now it's like double the price, right? Fuel has increased astronomically within the last 2 years. Most of it is due to the fuel subsidy removal, and some of it is due to the ongoing Iran war. Now we need to move from an era where our mobility is mostly dependent on fossil fuel to a future where we have alternatives. Because if you want to move from A to B today, you have to using road travel, you have to use an ICE vehicle. You have to use an internal combustion engine vehicle. That's like a petrol vehicle to move from point A to point B. There are no alternatives, or there are no widespread alternatives, right? Now, if there were alternatives, it would have been easier for us to boycott petrol vehicles. Now that the price of petrol or fuel has increased, assuming we had alternatives like EVs are very widespread, would have said, "Oh, I'm not going to use fuel again, a fuel vehicle again. I'm going to switch to using EVs." But we do not have the alternative yet. Now, another reason why mobility needs to change is because of the high maintenance of ICE vehicles, that's petrol vehicles. Now, if you buy a petrol vehicle today at 20 million, over the lifetime of the vehicle, you definitely spend like 10 million on the maintenance alone, right? And if you're taking the fact that most Africans or Nigerians use they use a second-hand vehicle, right? This even increases the cost of maintenance. And you're taking the bad road, the fact that um you have to do consistent oil changes, engine and all, it's the price of your maintenance keeps on going up. Now it's a bit worse here because we tend to buy second-hand vehicles, as I said before. Now we also there's also the unpredictable operating costs that is linked to the volatility of fuel prices and maintenance expenses. Today, a liter of fuel can be 500. Tomorrow, you don't know how high it will go. I mean, in 2023, we were buying it at about less than 500, and before you know, from 500 it went to like 1,000, and now it's like 1,3. Using Nigeria as an example, that is how it is here, and so on. And even for maintenance, your vehicle can be fine now. You can be using a vehicle like it's going fine now, and before you know, tomorrow there's like an engine problem, there's like an oil problem. There's just something that's going on with your vehicle that's unexpected. This increases your these are your unpredictable operating costs that you did not have in mind, right? This is a very important reason why mobility needs to change. Lastly, we have the increasing pressure to reduce emissions. Now that the world is trying, we're trying to every country is doing their best to reduce their carbon emissions. We are now being more conscious about the environment, right? Every country is looking to reduce their emissions, which is why mobility needs to change. We are using IC petrol vehicles for transportation. That wouldn't change. We still have more carbon emissions. We still have more polluted areas. Right. So these are the reasons why mobility needs to change for us. Now we're introducing us into the electric vehicle ecosystem, and where we have like about um eight stakeholders in the ecosystem. Sorry, okay, apologies. So moving on into the electric vehicle ecosystem, where we have about eight stakeholders in the market, in the ecosystem, sorry, that have each of which have like a a role to play in the growth of and adoption of electric vehicles. First, we have the vehicle manufacturers, which we refer to as the OEMs. Now, the OEMs are needed to design, engineer, and assemble electric vehicles, which can range from two-wheelers, that's your electric bikes, to your three-wheelers like your keke, and to your four-wheelers like your private cars or your logistics van or just cars basically. And their role is simply to manufacture electric vehicles at prices that the market can easily adopt, right? And some local players that we have here in Nigeria are I think some the players that we have in the market. We have I'm sure everyone knows like BYD, and so that's like the most popular one. And sure, Tesla as well. Those are the vehicle manufacturers. They are under this vehicle manufacturer stakeholders in the EV ecosystem. And second, we have the charging infrastructure providers, who are also known as the charging point operators, and the equipment manufacturers. That is so the equipment manufacturers are those that make your chargers, like the AC charger and the DC chargers used for charging the electric vehicles. And there's also the mobile chargers used for, you know, okay, so mobile chargers are basically chargers that are on wheels. You can move them from point A to B. So if your vehicle spoils on the road, you can have a mobile charger at the trunk of your car that has it's like a power bank, more or less. Yeah, it's like a power bank that charges your vehicle on the road. So those equipment manufacturers are under the charging infrastructure providers, right? And we can also include those that manufacture solar panels, because solar panels are also used in charging stations. So, and their role is to install both public and private charging stations for for electric vehicle users to charge their vehicles. Then we have the energy providers, and this comprise of utility companies, independent power producers, and these stakeholders are needed to generate and distribute electricity. If you're looking at Nigeria, we're looking at the AEDC, those who are in charge of basically giving everyone lights at one point in time or the other, right? They are necessary for them to supply the electrical grid capacity that needed to support electric vehicle chargers and ensure that the generated electricity increasingly come from renewable sources. That is, instead of using power plants, we are able to use wind turbines or use solar panels so as to reduce our carbon emission as well. And then we have the software platforms. These software providers, such as the telematics, the charging point management systems, and the fleet management platforms, they act as the ecosystem digital backbone. Now, their role is to ensure the ensure and sorry, their role is to ensure the interconnection across different charger brands and enable smart charging to avoid grid overload and sorry, can you still hear me?
Yes, we can. I can still hear you.
All right, sorry, thank you. Thank you. Okay, so their role is to ensure the capability across different charger brands. They enable smart charging to avoid grid overload and provide real-time work analysis using protocols. Right, so they're basically there to monitor your charging, to monitor your fleets, and make sure that everything is working together. That is, the vehicle is communicating effectively with the charger and so on. And then we have the financial institutions such as your banks and investment firms and green funds that provide the necessary capital across the ecosystem. So EV industry is still quite big and it's going to demand a lot of infrastructure for it to be easily adopted. Now, EVs are currently very expensive, and we would need the financial institution to provide innovative ways of people to adopt electric vehicles without being burdened by the upfront cost of it. Right. So their role is to offer assets financing for fleet vehicles, grants for infrastructure projects like charging stations, and funding. We also have the government and regulators, which comprises of the local, the state, and the federal authorities across all electricity commissions. Now, their role is to establish the guidelines, the incentives, the scrapping policies, and special electricity tariffs orders that drive or hinder AV adoption. That is like for them to say that okay, if you have an EV, you don't have to pay taxes, or if you are importing an EV, you don't have to pay the importation fees, things like that, or the import duties, things like that, so that EVs can be more adopted in the country. Then we have the fleet operators and the end users, like you and I, right? And these are people who utilize the electric vehicles. We represent the demand side of the market and require easily acceptable public chargers to facilitate the widespread adoption of electric vehicles. End users need chargers to, charge their vehicles, right? So even if you get an EV, if you don't have a charger to charge it, you can't use it basically. Lastly, we have the maintenance. Now they are involved in the upkeep of the vehicle. Traditional mechanics cannot service electric vehicles without specialized tools. Now, the EV ecosystem is an interconnected network where vehicle manufacturers build electric vehicles, they build two-wheelers and trucks, while fleet operators and end users adopt them. Now, the hardware is built by charging infrastructure providers and energy providers, and they are managed via the software platforms. Software platform keeps track of everything, and everyone in the ecosystem is backed by the government and the regulators and financial institutions.
Hi, Rejoice. Can you hear me?
Yes, I can hear you.
Since you're not sharing your screen and your presentation slide anymore,
Oh, you can't see it.
we can't see it currently.
How about now?
Yes, you can see it now. Thank you.
All right, apologies. All right, so moving on into the role of data in the EV mobility. Now, the focus of this slide is to highlight the critical role that data plays in electric vehicle mobility. Now, let's start with the driver's behavior. Data can be collected to understand how drivers operate their vehicles, which can help in improving safety and efficiency. Now, EVs are basically computer on wheels, and there's a way that you would drive that vehicle that it will reduce the battery life of the vehicle, right? So this is very important to know. It's important for us to get the data of the driver's behavior so that we are able to address it. Like, you cannot drive this vehicle like this so that you do not reduce the battery life. Next, we have the energy consumption. Now, we're monitoring how much energy each vehicle uses for better planning and management of resources. It's monitoring like monitoring how each vehicle behaves, how much energy is being consumed by each electric vehicle. Then we have the state of charge of the vehicles, and this data is crucial for ensuring that vehicles are charged optimally and ready to use when needed. You need to know if you are going for example, for a logistics operator, if they are going for a delivery, they need to know how much battery they have, how much power they have in the vehicle, so that they can effectively deliver and come back. And we need the data. We need this data so that we can for route optimization and for other things as well. As we go on in the presentation, we'll be able to see where these data has come to use. Then we have the battery health, which is a very important factor. By keeping track of the battery condition, we can extend the life of the battery and ensure reliability. We're able to know by getting data of of the battery's health, we're able to know when the rate of the degradation, or we're able to know when it's to finally give up, or basically or preserve the lifetime or life cycle of that battery. Then we have route efficiency, which is another area where data is very valuable, because by analyzing the routes, we are able to optimize travel time and reduce energy usage. It reduces the amount of time you use to travel from point A to B by finding the most effective routes, right? And then lastly, we maintenance requirements that can be predicted and planned through careful data analysis, but it can also to reduce unexpected downtimes and costs. And from the data gotten from the vehicle telematics, we can determine when maintenance is needed. So depending on how the vehicle is used, depending on various factors and the various data we're getting from each of the data that we're getting, we're able to determine when the vehicle needs to be maintained. So instead of reactive maintenance, that is when your vehicle spoils, that's when you go to repair it. We are able to use predictive maintenance to fix the vehicles and keep them um in shape, basically. So every EV generates a wealth of data, and using this information effectively is essential for enhancing performance, sustainability, and cost efficiency. Now, EVs are basically computers on wheels collecting data independently, and how we um how we leverage this data is very important. Now, we're looking at the AI applications in mobility. So in this, okay, so everyone is aware of what AI is, artificial intelligence, and no matter where you are in the world and what you're doing, basically every platform and every app uses AI in one way or another for their systems, for their daily lives. In fact, every one of us should use AI in our daily lives, and it's the same thing for the immobility space. AI is transforming the mobility sectors in a lot of areas, and we'll be exploring some of them right now. First, we have the demand forecasting, where AI-driven predictive modeling helps anticipate the rider surges and charger usage across networks. Excuse me. Now, this means that we can better manage resources and meet customer needs efficiently. That is, for example, during Christmas period, AI is able to tell you that, okay, um, during this period, you're going to have a lot of deliveries. That's, for example, a logistics operators or an FMCG distributor, right? AI is able to tell them that, okay, you need to supply this particular goods to this person, or during this particular season, there is a rise in this number of goods that needs to be delivered. So AI is able to tell through demand forecasting, right? And once you have that, you're able to be like, okay, I need to charge this vehicle right at this point in time. I need to be able to know which station is free, which vehicle is free, and basically do manage your customers well. Next, we have the predictive maintenance that we mentioned before. Now, by using the sensors to forecast component failures based on the historical data we've gotten, the AI minimizes the downtime by addressing issues before they lead to breakdowns. This is crucial for keeping fleet operational with minimal disruptions, right? So depending on okay, so the vehicles have sensors, and these sensors generate data that can be displayed and saved. So the AI takes this data and is able to use it to predict maintenance. Okay, this vehicle has been used like this from this time to this time. Is this part still working? Is the battery still good? Is the motor still good? Is the braking still good? So it's able to determine when predictive maintenance is supposed to occur based on the data that is gotten from the sensors. Then we have the driver rate analysis. Now, the telematics monitor the driver behaviors to reduce accidents and insurance costs. Now, through the telematics, AI is able to monitor the driver's behavior, which helps to reduce accidents and lower insurance costs. Now, this approach is to safety is a game changer for both individual drivers and fleet operators. Now, look at it like this. For example, if driver A breaks, like aggressively breaks 15 times daily and frequently exceeds his speed limits, and then we have the driver B that is driving smoothly with consistent speed, we're able to determine which driver is better, basically. And when it comes to now, we're looking at the battery health monitoring. AI is able to track the degradation patterns to extend the total battery pack lifespan, right? So this not only saves cost, but also contributes to sustainability efforts by maximizing the use of existing resources. It basically tracks the condition of the EV battery over the time to understand its performance, the remaining capacity, and the potential issues. So, for example, when a battery is new, is for example a battery when it's new, it can have like 100 kilowatts per hour, right? That's the battery capacity, and then as it's being used, that capacity reduces as time goes on. Now, the system or AI is able to estimate the remaining battery life, the replacement timeline, and the performance decline. It's able to tell when we will need to replace this battery. It's able to tell the rate at which the battery is degrading. It's able to tell the how much time is left for this battery packs up, right? And then we have the fleet utilization optimization, right, which is another area where AI can be effectively used, which is in smart scheduling that ensures that the right vehicle is smart to the right job, right? So you have for a fleet operator, it has like a large, like over 1,000 vehicles, and is they're able to AI can help them to effectively schedule their order so that there's a vehicle per time for all of their operation. Or if they have like a mixture of vans and trucks, they're able to utilize all of these assets for their operation. Finally, we have the route optimization that we mentioned before. Now, AI can adjust the paths based on traffic and terrain, and that's ensuring that the timely and efficient travel is determines the most efficient route for a vehicle to complete deliveries while considering different factors like the traffic, like the road condition, like the delivery priorities, the vehicle range, the battery level, the distance, and the time windows. Now, with this AI application, the mobility sector is not only becoming more efficient but more sustainable. Next, will be exploring the how AWS supports these advancements. Now, we're diving into how AWS powers modern mobility. Now, think of an EV as a computer on wheels, and now every second, this particular vehicle, if this electric vehicle, it generates information on the battery level, the location, the speed, the energy consumption, the driver's behavior, and the vehicle's health. Now, the challenge is what to do with this information. If the vehicle generates all this information, what do we do with it? How do we use it? Now, that's where AWS comes in, right? First, we have one of the applications of AWS in um, modern mobility is the cloud infrastructure. Now, cloud infrastructure is simply computers and servers hosted on the internet rather than your office, basically. Now, instead of buying expensive servers and maintaining them yourself, we have companies like AWS that does that for you. They run your applications and they store your data. Now, for example, let's think of a fleet operator with 1,000 vehicles that receives millions of data points every day. I remember I said that one vehicle can generate different data based on the battery level, the location, the speed, the energy consumption, the driver behavior, and the vehicle's health. Now imagine that's being multiplied by 1,000 vehicles giving you that data. That's like all of like seven of them or for each vehicle, right? So that's a lot of information, right? Now, the AWS provides the computing power needed to process that vehicle's data, to run a fleet management software, to serve dashboards to your customers, and to scale as the fleet grows. You can't keep all of those data as a lot, so you need somewhere that you can keep it and process it. It's like when before when we're using when we're using files and cabinets to keep those data, right? So now if you want to maybe process the data, you can't effectively do that. But AWS has the power, the computing powers to do that. That is where it comes in for the cloud infrastructure. Now we can use a version of AWS is in IoT, that's Internet of Things connectivity, which enables communication between devices, that's physical devices and softwares. So it basically means that physical devices are connected to the internet, like your EVs, your GPS trackers, your battery management systems, your charging stations, all connected to the internet, right? And I think of it like this, like an EV that sends information about the battery charge, the location, and the speed to the cloud every second. AWS will receive that information and manage that communication. Next, we have the data storage. Now, AWS offers secure and scalable storage solutions, which are very essential in handling um, a large amount of data generated by electric vehicles. Now, once this data is collected, it must be stored somewhere, and AWS stores these information such as the vehicle's trip, the driver's records, the battery history, the charging sessions, the maintenance records, things like that. So a logistics company, for example, they're able to tell how much energy one vehicle consumed in the last month, how much the vehicle A consumed last month. And this answer can come from the stored information that AWS has. Then we have the real-time analytics. AWS also delivers real-time analytics, which means that mobility platforms can process and interpret data instantly instead of leading to quicker decision making and improved efficiency. Now, analytics can turn all the raw data that the EV is generating into useful information. Now, real time analytics means analyzing information immediately as it arrives, For example, a fleet manager is able to see the current vehicle locations, the battery levels, the delayed deliveries, the charging status as they happen. Instead of waiting for the next day, they're able to see it as it happens in real time, and they're able to make like quicker decisions. Then we have the machine learning. So machine learning basically allows computers to identify patterns and make predictions from data that's gotten from the electric vehicles. So we're able to predict battery degradation. We're able to predict vehicle breakdowns, traffic delays, and future delivery demands. Now, similar batteries usually fail, showing certain warning signs. And once you have that historical data, you're able to tell it. Now, machine learning helps mobility companies to predict future events without instead of only reacting to the problem. Finally, we have security, which is a top priority, and AWS ensures that all data and operations are protected against threats, maintaining the integrity of the mobility platforms. So if you bring it all together, basically is the vehicles, that's the electric vehicles that have sensors, and those sensors are able to send data or generate information and send it to the AWS clouds, which is able to give us process the data, compute it, and give us analytics, and which also helps in making um, effective business decisions. So moving on, we are going to be using a reward example, right? We are using sorry, so we are using a real world example. Let's say a logistics operator. A logistics operator. Now, Chinese, as I mentioned earlier, Chinese is sorry, someone speaking.
Yeah, Bishop, can you hear me?
Yes, I can hear you.
Yeah, can you please start rounding up so we can have time for some questions?
All right, thank you. So sorry. Yeah, okay, so like I said before, Charlie's we're helping logistics operators to easily transition to using electric vehicles. So a real example of a company before they use trolleys, they are manually tracking their goods. They have like fuel uncertainty, and they have reactive maintenance. That is, they maintain when the vehicle has already broke down. But trolleys, we provide the electric vehicle, we provide the we don't provide EV, sorry, AWS cloud, but we also use AI for our dealings. So they are able to see the real-time visibility, predict maintenance, and lower their operating costs and better use their vehicles. Now, what is the opportunity in Nigeria? Why do I, as a person, why do I, as someone in this space, why do I believe that there's opportunity in Nigeria? Now, when many people think about electric vehicles in Nigeria, they really focus on the challenges like the charging infrastructure, the financing, and awareness. While these challenges are very real, I believe that it also is equally important to look at the opportunity. Now, Nigeria has one of the largest transportation and logistics markets in Africa, and every day thousands of businesses move goods from between warehouses, between houses, between markets, between retailers and customers. At the same time, transportation costs have increased significantly due to the rising cost of fuel and the vehicle maintenance costs. Now, for many logistics operators, fuel is one of the largest operating expenses they have currently, which creates a strong economic case for electric mobility. Now, unlike in some developed markets where EV adoption is primarily but is for environmental concerns, in Nigeria, the biggest driving factor for electric vehicle adoption is cost savings and business efficiency. Nigerians are not really focused on the environment, but they're more focused on seeing how electric mobility is able to keep their business going, keep money in their hands, right? So another important trend is the rapid growth of e-commerce, last mile delivery, FMC distribution, and urban logistics. Now, as these sectors grow, they are looking for ways to reduce their operating costs while maintaining their service quality. We also see improvements in digital infrastructure, cloud adoption, telematics, and fleet management technologies. All these technologies are getting better by the day, and they make it easier for businesses to monitor their vehicle and optimize their operations. Now, I believe the adoption journey in Nigeria will not start with private electric vehicle owners. I believe it starts with commercial fleets like logistics operators, delivery companies, and businesses that that really use these vehicles for their day-to-day operations. Now, once these businesses demonstrate economic flow, broader adoption can follow. The opportunity is not to just deploy electric vehicles; it is to build an entire ecosystem around them. We have charging infrastructure, fleet management platform, financing solutions, energy services, maintenance networks, and data-driven mobility solutions. Now, companies that help solve these challenges today will play a major role in shaping electric mobility in the future. Now, the challenges that we must solve, we have challenges in Nigeria, we have in vehicle financing, in charging infrastructure, grid reliability. There is no consistent light, and we need policy support from the government where businesses electric vehicles are given leeway, and there is more incentives to encourage the adoption. And we need technical talents, people who can fix electric vehicles, people who understand the IoT, connecting charging infrastructure and electric vehicles to the internet. We need technical talent, and we need public awareness. We need to educate the public about the benefits of electric vehicles, that there are things that should be used that will be effective in their business. Lastly, the future of mobility in Nigeria. So looking ahead, it's clear that the future of mobility is about much more than just replacing petrol or diesel vehicles. The real transformation is intersection between transportation, energy, data, and technology. Vehicles are becoming increasingly connected, and instead of operating as a standalone machines, they are becoming part of a larger digital ecosystem that can communicate with fleet managers, charging infrastructures, software platforms, and cloud services in real time. We are also moving towards a future where decisions are increasingly supported by data and artificial intelligence. Rather than reacting to problems after they occur, businesses are able to predict maintenance needs, optimize their routes, um, monitor vehicle performance, and improve operational efficiency before issues impact their operations. So the future of mobility is their connected vehicles. Every vehicle, we know where the vehicle is, we know what happened in every vehicle. In every vehicle, AI connected powered fleets through fleet management platforms, autonomous decision support, AI giving us data for us to make quick decisions. We have smart charging network and sustainable logistics. Now, at Trialise, we believe that the future of mobility in Africa will be electric, to be connected, and to be data driven. Our goal is to help make sure that future is accessible and enabling a practical path towards electrification. Thank you.
All right. Thank you very much, Joyce. Thank you very much. So please let's have some reactions from those that are currently with us. Let's have some reactions just to show some appreciations. Thank you very much. I really appreciate the insight you shared so far on the electric vehicle ecosystem in Nigeria. Thank you very, 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 very much, right? So since we don't have too much time anymore, please start dropping in your questions on the comment section. Start dropping in your questions. This first speaker has said a lot about the EV ecosystem, the batteries, the data, the charging sections. She has said a lot. She has covered all that we really need to know on the introduction aspect, right? So I'll just walk us through some services in AWS that enables EV and mobility. These are some of the services that powers it. So she mentioned a lot about what we call the IoT, right? The Internet of Things. So I'll go column by column. So the first column we have here is the IoT, right? So AWS services IoT. So we have what we call the fleet-wise, which is a purpose built for automotive, like the EVs, right? It is natively, it understands the bus signals, as she had explained. So it can also stand for the what we call the area network. It helps the communication backbone that connects the electronic control units, right? So that's one of the services. Then we have the data and analytics column, like you can see on the slide that I'm sharing, right? One of the services in AWS that we use is called the Amazon Kinesis. This service in AWS is a real-time data highway. So what it does is it ingests millions of events per second from the vehicles, right? From the chargers, from the grid sensors. And what it does is that it makes them available instantly for processing. So you're able to know what this vehicle is currently going through. You're able to know the current consumption of that vehicle, right? With services like this right in AWS. We have the artificial intelligence column. One of the services we have in AWS is the Amazon SageMaker. We have the Amazon SageMaker, which is where serious model building happens. So the electric vehicles companies, they use it for, like the first speaker mentioned, the battery, how the battery is doing, how the battery is going down, and the life of the battery as well. We also have Amazon Forecast. So Amazon Forecast is a purpose-built time series, which is used for forecasting services. You're able to predict ahead, even the energy demand of these EVs. So these are some of the services. On the compute and the storage column, we have the popular EC2, Amazon EC2, which is Elastic Compute Cloud, right? We have that. We have the Amazon S3, right? We have the AWS Lambda. We have the EKS, right? So we have some of these services in AWS that can be used for effective management of EV and mobility. On the connectivity column, we have services like Amazon Direct Connect. We also have services like the CloudFront. We have the content delivery network, right? So it helps to accelerate the delivery of the firmware updates. So from these services that AWS uses to power EVs and mobility, here's the message I want to leave on this slide. So you don't have to build this infrastructure. AWS already has it. It has already built it. Especially, let's say you are an EV company producing either the cars or the fleet, then the charging stations, right? So AWS already has this. It has been tested and it's in scale and it is already available. So your job and our job at Authorize Integrated is to connect it to your specific electric vehicle challenge. Last week I mentioned a lot of challenges that we face currently, right? So the AWS services ensures that we're able to handle these challenges. We all know the challenge of network, right? Not every area has strong internet connection. So the services in AWS ensures that these solutions can work with minimal internet connection. So these are just some of the services in AWS that can be used to power mobility and EV. So we have this sustainability commitment as well. So I'm trying to keep track of time so that we can have some time for questions. So please start sending in your questions to the comments section, right? Start sending in your questions. So let me highlight this. Somebody mentioned this in the chat here. He said, I care for the environment. He said he cares for the environment a lot, which is what every one of us also does. We all care for this environment. So one question someone would want to ask is, we are talking about EVs, right? We're talking about mobility, and then we are now talking about AWS. How does AWS come in? And also, how does renewable energy come into this discussion? this is the take now. You know, these EVs, they are powered by electric, right? There is no fossil fuel used in them. They are powered by electric. So now, how do you generate electricity to power these electric vehicles? So if we're going to still burn diesels, right, to power the electric vehicles, we're just still on the same spot. But renewable energy now comes in because we now have these renewable energies, solars, to power our system that powers the EVs. So renewable energy comes there because we also care about the environment, right? So these are some of the things we have here today. I'm still expecting some of us to drop our questions so that we can handle them one after the other. Still expecting our questions to start rolling in. So let me go to some of the real-world EV use cases on AWS. So we are not just talking, right? AWS is already working. AWS is already doing this. We already have services in AWS that handles all this. So this is where it stops being just theoretical. So I'll just pick some of the most important use cases here. So for case one, we have the predictive battery health. Battery degradation, like the first speaker mentioned, is one of the biggest anxiety of electricity vehicle and the operators themselves. So it affects the resale value. You know, most people use foreign use vehicles. But if we're using electric vehicles, for example, are we able to manage the batteries in a way that it doesn't degrade so fast? And it also has a resale value, right? So we have use cases on AWS already. So what AWS service that comes into play here is the AWS SageMaker. So what it does that it allows us to train the machine learning models on charging cycle history. So we're able to train them on the charging cycle history. And then it also helps with the temperature logs and then the usage patterns, how it should be used, and then the change, the states of the charge data. So the data that's in the solution now, what is the current state, right? It helps us to manage that as well. And one Amazon web service customer reduced unplanned maintenance events by 35%. This is already happening, right? So this is not just theory and theory and theory. This is already in use. And then if you take a look at the use case number 5, which is the vehicle to grid, which we abbreviate here as that's the V2G. That's the vehicle to grid. It is one service that is currently underappreciated. And I think it's going to be one of the most important developments in energy in the next decade, where every electric vehicle battery is essentially a distributed energy storage unit. So vehicle to grid technology allows that battery to push energy back to the grid when demand is high. So what it does, it now turning your fleet into a virtual power plant, right? So we have a lot of use cases here. We have the predictive battery health. We have the smart charging optimization. We have the OTA software updates, the EV fleet management, vehicle to grid. We have the autonomous and the ADAS simulations. So we have so many use cases already. Now to round up, right? I want to leave us with 5 things in our mind, and I'll be quick because of the time already, right? So AWS services covers the full stack from the vehicle edge all the way to the artificial intelligence and the analytics. So what it means is that you don't need 5 different vehicles. It's just one platform and it's on AWS. One set on security, controls, one view. What it means here is that data is the new fuel. The electric vehicle companies that captures, processes, and then acts on the data fastest is the one that wins. So on range, on battery life, on customer experience, AWS gives you the infrastructure to do that at a scale right from day one. So if you want to scale up to 500 EVs from day one, AWS has it. According to the numbers, most EVs that are operating in Nigeria currently are still operating around hundreds. They've hardly reached 200 EVs on the road of Nigeria per operator. So no matter the numbers, AWS provides what is needed. Then now the sustainability. So sustainability is built in. What this means that choosing AWS services is itself a sustainability decision. We have 100% renewable energy, net zero commitment, and a suite of services purpose-built for clean energy ecosystem. So we are not going to borrow services. The services are specifically built for EVs and every kind of EV in this ecosystem. So this is proven, not promised, right? It has been proven at scale. A lot of companies have been using it already. So everything that we have shown you today is in production and is being used by real customers. So this is not just a roadmap, it's already shipping. And finally, Authorized Integrated is your shortcut. So as an advanced tier partner with AWS, we architect these solutions before. So we know where these sharp edges are. We know what to look out for. We know what to integrate. We know what to implement. So we know these things already. So integrating with AWS and Authorized Integrated, we bring these services to life, right? So these are some of the points that I want us to go home with today. So let me check if we have some more questions on the comment here. Okay. So Rejoice, can you hear me? So we have a question here. Rejoice, can you hear me? So Paul,
yeah, I can hear you.
Okay, can you see the question? I'm displaying the question
Yes,
currently.
I can.
All right. So he's saying that from your experience at Trilys, what's the opportunity cost for logistics companies using EVs compared to the ICE vehicles? So is it ultimately more cost effective, EVs to ICE vehicles? Is it more cost effective? Can you respond to that?
All right. Yes. Hi, Paul. So yes, it's more cost effective. So think of it like this. So you buy, or let's also do like a quick calculation, right? So if you buy a vehicle, let's say you buy a second-hand vehicle for like um 4 million, 4 million naira, then currently let's assume the price of fuel is about 1,300, right? So I'm looking at a logistics, yeah, as you said, logistics company. So they buy a van for 4 million naira. That's even very low. We're looking at almost 50 million naira actually. They multiply it by, they have to buy vehicle, sorry, they have to fuel the vehicle every day. So let's look at it for like a month. That's like about 28 days, or just let's just do 30 days, right? So they have to fuel the vehicle every day. 30 days times 1,300 for, that's like 39,000. That's per liter. And they need like up to 12 liters um just use every day. That's about 500,000 every single month by logistics operators. Right? I don't know if you get the calculation. I was really fast about it. But basically, it's more cost effective because if you think about the cost of the vehicle, the cost of the maintenance, the cost of fueling that car is very high. Now look at electric vehicles. Electric vehicles, yes, the upfront cost is much higher. It's like times three times higher than I'm getting an ICE vehicle. But then think about the long-term savings. No more fuel price anxiety. You're no more thinking that fuel has increased. That means I have to move some of my profits into buying fuel now. No more maintenance issues because you have less moving parts of the electric vehicles or in electric vehicles. Now, actually, what we are doing for operators is that we're now spreading the cost of the we are spreading the cost of the of buying the vehicle of buying an electric van for their operations, right? So we are giving them like a one-time monthly payment. So you pay that payment every month, and that payment covers like part of the vehicle, covers your maintenance, covers your insurance, covers your charging for that month, and you're just using that vehicle for your operations. So I hope that answered your question.
All right, thank you very much. It's actually more cost effective. So, like the speaker explained, the upfront might look more effective, but on the long run, it's the EVs that win on the long run, right? So, thank you very much for responding to that. So, we also have the other law says that the EV sector has created millions of jobs across manufacturing, engineering, software development, battery production, logistics, and infrastructure development. So this is very true, right? So just, I don't know if you want to speak on this as well. The fact that this EVs has created a lot of jobs, millions of jobs. Do you want to also trade an input on this?
Yeah, sure. So, yes, you're right. It has and will create a lot of jobs across manufacturing, engineering, software development, battery production, logistics, and infrastructure development. And for me, if I'm looking at Nigeria's future, this would help us to move more into infrastructure developments because for a long time we have done more of softwares. So I believe it's time for us to move into the hardware, and I believe that EVs will usher the way in. So now we're going to be seeing a lot of battery production, not only battery production, but battery production for the African climates, for the Nigerian climates, batteries that can withstand the heat in different parts of Nigeria. We're also looking at manufacturing of the charging equipment, your chargers, your the AC charger, your DC charger, your mobile chargers, and even enabling basically everywhere in Nigeria should have like a charger, even if it's a mobile charger. And we are also seeing infrastructure deployments in charging stations, high in on the highways and depot charging stations in markets where people can leave their vehicles overnight, come back the next day with a fully charged vehicle and continue on their business. So yes.
All right, thank you very much. Thank you very much. So please, let's drop some reactions on the comments. Let's drop some reactions. Whatever platform you're joining this live on, come on, let's drop some reactions. It has been a very wonderful and amazing time. It has been one of the most productive and the most informative hour of the week. So let us send some reactions. That's been very amazing. Rejoice, we are very grateful. Thank you very much for making time to be here today. Let us also not to forget that this webinar continues tomorrow. This webinar series continues tomorrow. Also prepare to be here tomorrow. The webinar series continues till Wednesday as well. And then on Thursday, we're going to be having the main event. You don't want to miss any day of this webinar series, and you also don't want to miss the main event. You don't want to miss it for anything in the world. So let us prepare to attend the series that's going to be happening tomorrow, the one that will happen on Wednesday, and then the main event that's going to be happening on Thursday. Don't forget, the topic is powering mobility and the EV ecosystem with AWS. Thank you very much, every single person that joined this live webinar today. Thank you very much. We are grateful. We hope to see you tomorrow. We hope to see you the day after tomorrow. And then we hope to see you after the main event on Thursday. Rejoice, thank you very much. It has been an amazing time with you today. Thank you very much. We're very grateful. All right, guys, thank you. That'll be all for today. See you tomorrow. Have a nice day.
Thank you. Hi.